Good morning. Today we have a question I want us to look at together. This is 16.8 gram of sodium hydrogen carbonate 4, that is NaHCO3. Remember that you have something like Na plus HCO3 minus. This is the radical. So that is how we derive that formula NaHCO3. So now coming back to this, is decomposed. That means it was broken down, decomposed. They said by heat. So there's going to be heat here. Automatically, this type of reaction is a thermal decomposition. I'm going to have Na2CO3 as a byproduct plus CO2 gas plus H2O. It's not left for me to balance the equation. So a solid. Now let's balance it. Sodium 1, sodium 2. Let me add 2 here. Sodium 2, we're going to balance it. Sodium 2, sodium 2. Hydrogen 2, hydrogen 2. Carbon 2, carbon 1 plus 1, 2. 2 carbon here. Oxygen is 3 times 2, 6. Oxygen is 3 plus 2, 5 plus 1, 6. So the equation is balanced. Now you're looking for the volume of carbon dioxide given off. Remember that 1 mole of CO2 gas contains 22.4 dm cube. So therefore, we're going to get number of moles of CO2 that was given off. Now let's go back to the equation. This is basic stoichiometry. They gave you 16.8 gram of this. I tell students, get the connecting factor. The connecting factor is NaHCO3 and CO2. Equate it together. Remember that molar mass is gram per mole. It means for 1 mole of a substance, you can get the mass. Now this is 2 mole. This will be 2 times. You can do it for NaHCO3. That will be 23 plus 1 plus 12 plus 48. I will stick together on this. I want us to get this thing right and correct. So here we have 168. When we multiply everything, this will be 168 gram of 168 gram of NaHCO3. Gave CO2 is always 44 gram of CO2. CO2 that is 12 plus oxygen is 16 times 2, 32. That is how we go 44. But you should get acquainted to that now. So that is for that. I suggested that I use the known to get the unknown. This is the known. Now the unknown, they gave you 16.8 gram. 16.8 gram. So I come back here, that will be, so therefore 16.8 gram of NaHCO3 will give us S gram. I'm trying to use stoichiometry process to get the mass of CO2 basically, because I need the mass. Number of moles is equal to mass over molar mass. I know that the molar mass of CO2 is 44. So if I can get the mass, I can get number of moles, which I'm going to use here to get the volume which I'm looking for. So coming back here now, you cross multiply. This is the stoichiometry process, which I used to call highlighting method. The quotient of x here is going to be 168. I want to make sure that we're saying it. So that will be, so therefore S is going to be equal to 16.8 times 44 over 168. This is 0.1 times 44. That should give us 4.4 gram. How to get 4.4 gram of CO2. So I now come back here. Number of moles is equal to mass over molar mass. The mass I got here is 4.4 gram. So that will be 4.4 over 44. 4.4 over 44 is 0.1 mole. So I can now come back here. If 1 mole of CO2 contains 22.4, so therefore 0.1 mole of CO2 will contain x dm cube. You cross multiply. X times 1 is x. Then 0.1 times 2.2 for that will give you, and 0.1 times 22.4 will give you 2.24 dm cube as a final answer. And we have the options there, and that is option C. That is option C. Yeah, let me just use a minute to explain the question again. This is the question. I tell students, you can't solve a question you don't understand. So the first thing is understanding this question. I get now 16.8 gram. You see that I wrote equation for the reaction. I needed the equation for the reaction. NaHCO3 will be broken down. They said in terms of it to describe that this is a thermal decomposition reaction. So those are the byproducts. I try to get the limiting factors. In A level advanced chemistry, there's also called Na, the limiting reagent, which is NaCO3. Again, the one that is given up and not used up completely. So I'm trying to use the known to get the unknown. Use the molar mass. I told that the molar mass that is the SI in the gram per mole. It means for one mole you have a particular mass. Now for 2 moles, I have a particular mass which is 168 gram of NaCO3. So 168 gram of NaCO3 gave 44 gram of CO2. This is the stoichiometry process now. Mass volume relationship. The mass of the reactant is equal to the mass of the product in a balanced equation. Then they gave me 16.8 gram, which I took here. 16.8 gram of NaCO3 gave me X gram of CO2. I want to get the mass of CO2 used up. So by equating it, and I get S is equal to 4.4 gram of CO2. So in this system, I have 4.4 gram of CO2. If I've gotten the mass, I can get number of moles. So number of moles, I want to get number of moles of CO2, which I'm looking for the volume. I first of all got the mass, so I can get the moles, so I can now get the volume. It is a step-by-step process. So number of moles is equal to mass over molar mass. I have 4.4 gram, which is the mass over molar mass of CO2, which gives me 0.1 mole. And I equate it using this method that I personally call highlighting method. A molar volume of gas at STP is 22.4 dm3. 1 mole of any gas contains this. So 1 mole of CO2 contains 22.4 dm3. CO2 was given off here. So and for this CO2 given off, the number of moles we had was 0.1 mole from this stoichiometric process. So therefore 0.1 mole of CO2 contains X. So by equating it, I cannot get the value for X. I hope you understand that carefully. Stoichiometry. Please, one of the most important things is the chemical equation, the balanced form. Like my lecturer used to say, an unbalanced equation is not an equation at all. Endeavor to balance your equation and is appropriate. Is going to help you, because if here I didn't use 2, or maybe I just ignored it, I just wrote NaCO3 and I just wrote everything, I didn't balance the equation. That means I will not use this 2 here, I will not get 68 here. Yeah, I'm going to get 89 or so. Again, and if I use 89 here and keep on solving, that means I'm just doing something off point. Unfortunately or coincidentally, or unfortunately or coincidentally, whatever answer I get may correspond with what is here. So that's why I tell you that I verbally cannot do science. So just calm down and follow the process.